the Mouse Whisperer on dragging a cat with a mouse, or the delta X and Y of programming a mouse. Programming the mouse is not as simple as it sounds, but you only need to know a couple of things. The mouse move is based on a timer, and you want deltas, not X and Y. Let us imagine we have a blank web page with a small photo of a cat in the center. I will show you how to drag the cat without bothering you with source code. I just want you to understand how to think about the mouse. For an actual tutorial, just search the internet for JavaScript Mouse Drag tutorial. The way we know that the user wants to drag the cat is by listening for the Mousedown event that we attach to the cat the moment our web page loads. Mousedown is the first half of a click event. The other half is mouse up. Here is the first unusual thing. Within the Mousedown event, when the user is pressing the mouse button, we must install a mousemove event listener. So until that moment, we don't know if the mouse is moving. We must also listen for mouse up, though now outside the Mousedown event, to remove the mousemove listener when the user releases the button. So mouse down and mouse up basically install and uninstall the mousemove listener that will drive our dragging of the cat. The mouse down and mouse up themselves are only removed when you want to remove the draggability of the cat on the web page. If you want the cat to stay draggable, just let the browser clean up when the user navigates to some other internet web page. Okay, this is where things get wild and confusing, and pretty tough. But what you have learned thus far shows you how to install a cat dragging function and clean up when the user lets go of the mouse. This is an awesome lesson already. It eases you down into the world of messing with the mouse. You install the mousemove inside the Mousedown and get rid of it on mouse up. Okay, grab onto something and just relax and listen. The mousemove event does not trigger each time a mouse moves by a single pixel. It actually runs on a timer. It samples the cursor position every 50 milliseconds or so, and if the X and Y changes, it then issues a mousemove event. The mouse is a pretty dumb device. It does not know about the size of the pixels on your screen, whether you are zoomed in or zoomed out. It doesn't know about the monitor or anything else. Think of the mousemove listener as a radio that now receives a broadcast of the mouse coordinate change every 50 milliseconds or so, if that change occurs. It is a really good approximation of tracking the mouse in great detail. So, for a simple overview, you can just think about it as whenever you move the mouse move event triggers, but not by a single pixel, but by a few pixels. Okay. Now things are gonna get worse. Maybe grab a snack or something. It's about to get pretty weird. Listen, we can't just use the raw X and Y coordinates of where the mouse is on the screen. Nope. Because if we used that X and Y and applied it to the image of the cat, we would ignore where on the cat the user has clicked. We would set the position of the upper left corner to the position of the mouse cursor, making the cat jump if the user was dragging the cat by its nose. Furthermore, we mustn't try to measure the distance from the upper left corner of the cat. Our cat here is just an example. This could be a deeply nested window in a panning and zooming application that can be nested in another panning and zooming application. You would need to measure every border, every margin, every padding, every offset of every box that we are nested in. And measuring scale, or the zoom in and zoom out, may not be something that we can go around. We may always need to divide by scale. And scale is actually a really weird measurement, because scale 0 means infinitely zoomed out, and scale 2 infinitely zoomed in. But let's leave it at that. The talk about working with zoom and pan system belongs in a text specifically about them. I will add a little bit more about this subject at the end. So let us now imagine that the user clicked in the center of the left eye of the cat, and that eye and the cursor must stay perfectly in sync while we are dragging. The now pretty freaked out creature, no doubt. To accomplish this, every 50 milliseconds in our mouse move listener, we have to figure out what the cursor position delta, or change, is. And we will apply that very tiny number of pixels that we know our cursor has now moved by to the X and Y of the cat image. So we don't set the coordinates of where the mouse is on the screen to the upper left corner of our poor cat. We figure out by how many pixels the mouse has moved in X direction and the Y direction, and we add this tiny number to the X and Y of the cat. So it is a relative calculation, relative to the previous position of the mouse cursor, and we apply it to the upper left corner of the cat, so that the cat moves by the same tiny amount of pixels that our mouse has moved. To set this up correctly and simply, you should capture the initial X and Y coordinates on Mousedown, and just call them previous X and previous Y. It's a little bit of a weird name to start with, but we are initializing here. And we will be saving real screen coordinates. We are always working with the coordinates of the viewport that you should think about as screen coordinates, because we are going after the delta only, the change between previous screen coordinates and the current screen coordinates. So we take a measurement of where your mouse pointer is relative to the corner of your viewport, and just for simplicity, let us imagine that we are in full screen mode, so that the corner of your viewport is the corner of the monitor. And on an old school 800 by 600 monitor, with our cat roughly in the center, we initialize previous X to 400 and previous Y to 300, the cursor being right in the middle of the cat. But as we install the mouse move listener here, and the user does move the mouse with the button pressed, inside the mouse move listener, we calculate the mouse delta, or change, or difference between previous X and Y and current X and Y. So we say delta X equals current screen X minus previous x. The previous x actually holds the previous screen x. And then we add delta y equals current screen y minus previous delta y. So if we moved the cursor right by 5 pixels in the last 50 milliseconds, our delta x would be 405 minus 400, which equals 5. If we moved the cursor left by 5 pixels, our delta x would be 395 minus 400, which equals minus 5. Once we have that little number that perfectly captures motion, we add it to the x and y of the cat. And because our cursor moved 5 pixels in that 50 millisecond period, the cat now moves only 5 pixels, and the cat's eye stays under the cursor. Again, we are not setting the cat position to the cursor position because we don't know where on the cat the cursor is, and we really don't want to calculate that. We are instead calculating how far the mouse has moved since the last time we sampled the position and applying the same values to the image of the cat. Once the mouse button is pressed and the mouse is moved, we move the image by the same x and y that the cursor moves. And now that we adjusted the position of the cat, we must update previous x and previous y for the next delta calculation. We set previous x to the current value of screen x and previous y to the current value of screen y, to the current position of the cursor. These are actual coordinates of the cursor, the x and y relative to the monitor corner, not the deltas. The delta is only applied to whatever you are dragging. Remember, at this point, the mouse cursor has already moved, so you're just synchronizing whatever you are dragging with where the mouse cursor is now at. Just to give extra information at the end, for the somewhat rare instance that you are in a pan and zoom system, although smartphones will be trying to implement their own pinch and zoom, and these calculations may become more frequent, if you are zoomed out, you will have to divide the delta x and delta y by your scale. And again, given that scale of 1 means no change, scale of 0 infinitely tiny, and scale of 2 infinitely large. So, at 50% zoom, your scale is 0.5. And your 5 pixel delta x would become 5 divided by 0.5, which is 10. When you are dividing by a fraction, you are asking how many of those fractions fit into the whole number. Our delta x in a zoomed out landscape is doubled, because those little zoomed out pixels need to do more work. When in the real world, unzoomed, we move by 5 pixels. But down in the zoomed out world, those 5 pixels are only half of what we need to do in order to synchronize the cursor with whatever is being dragged. As far as the web page is concerned, the pointer or the cursor is just far and away on the screen in a world that cannot be scaled, that is outside of the browser. I want to make it clear that the division by scale is just for daring user interfaces, edge cases, and crazy phones. Additionally, the web browser does have a movement X and movement Y that we could use as the delta, but those two are not yet fully supported, not consistently. There's also a much easier drag and drop mechanism, especially fun if you need to drop files in the browser window. But applying the deltas, being so relatively low level, gives you all the power you will ever need, including the power to go around browser bugs.